Good morning, everyone. Almost afternoon here, 11:54. So, this lesson here is about friction, and so we're going to go ahead and go through that. I'm going to talk about two different types, show you a couple example problems, and hopefully that'll be able to help you with that friction worksheet that I posted this morning. So, friction is the force that occurs when two objects or surfaces are in contact with each other. There are basically two types of friction. There's static friction and there is kinetic friction. Static friction is what I'm demonstrating right now by standing still. The bottoms of my shoes are in contact with the floor that I'm standing on, and I'm perfectly able to stand here with no problem. Kinetic friction occurs when one or both surfaces that are in contact with each other are in motion. So, for example, I rub my hands together like this. I'm demonstrating kinetic friction with my hands. Anytime you walk from one point to another in the building while you're here at school or wherever else, you're demonstrating kinetic friction. Kinetic friction can be sometimes a little hard to come by this time of year when the roads are slippery. I don't know about you, but I really don't find it to be too fun to slide off the road or slide at all while I'm driving my car. So in a lot of cases, friction is definitely a good thing to have, in daily life, for that matter. So again, friction at rest is called static friction. Friction in motion is called kinetic friction. Perhaps you know of kinetic energy. Kinetic energy, of course, means energy in motion. Now, I'm going to show you how to calculate both static friction and kinetic friction right here. And we'll go on from there. All right, so calculating static friction, you have a formula that looks like this. This is called F sub S equals mu sub S times F sub N. F sub S refers to the force of static friction. That's going to be equal to, there's this Greek letter called mu. Kind of like pi is a Greek letter, 3.14, whatever else comes after that. Mu is another example of a Greek letter. Mu here refers to the coefficient of static friction. And that's what it is. It's a coefficient. There's not going to be any units with it. It's just going to be a number. And for our intents and purposes, that coefficient will be provided unless you have to solve for it, which I'll show you that here in a little bit. So we're going to take the force of static friction, and it's less than or equal to, this is actually an inequality, less than or equal to the coefficient of static friction times normal force, F sub N, which is normal force. Now, normal force, here's the definition. It's kind of long and drawn out, but that's how it is. It's a perpendicular contact force exerted by a surface on another object. It is oriented in the direction that is opposite of gravity and is equal to the object's weight in newtons. So, for example, if I have a surface and I have a crate sitting on the surface, we know that gravity is holding this thing down. You have the force of gravity. The normal force is oriented this way. Pretend like that's a straight line that I just drew. And notice that it is perpendicular to the surface of contact. All right? Now, to figure out the normal force, what you need to do is make sure it's in newtons. And for our intents and purposes, what I'm going to do is I'm going to give you the object's mass. 5 kilograms, 8 kilograms, whatever the number is. It's in kilograms. You have to convert that to newtons before you proceed. You don't want to just take, for example, 15 times the coefficient of friction, which in this case is 0.18. That's not what you want to do. You want to apply this formula right here. I'm going to put a red box around it. I don't know how well it's going to show up for you. But you want to take the mass that I provide you and multiply it by gravity. Now, notice that we have a negative number times a negative number. That's okay. What we typically do in physics is we assume that the downward direction is positive. So since normal force is oriented the opposite direction of gravity, the opposite of positive is negative, so we just call this a negative, it's a negative value, but when you multiply the two numbers together, negative mass times negative gravity, you still get a positive number. If what I just said about negative times negative is confusing to you or whatnot, then just remember, just take mass times gravity. All right, that's the first step. Figure out the normal force, take mass times gravity so that you get that normal force figured out. So in our example here, the box's mass is 15 kilograms. Calculate the force needed to overcome the static friction between the box and the floor. So it's like you're going to want to move this box across the floor, but you can't quite get it started yet, so you're kind of, it's like it's stuck there on the floor. All right, so what you need to do first is figure out the normal force of that box. Well, you know the mass is 15 kilograms because I gave that to you, and again, the mass values will always be provided. So what you want to do is convert from kilograms to newtons. To do that, multiply by 9.8. You're going to follow this formula here, negative mass times negative gravity equals normal force. When we do that, we get 147. The coefficient of static friction is 0.18. So we got that number, that will be provided for you. So then you can go ahead and plug the numbers into the formula. 0.18 times 147, and you're going to come out with 26.46 newtons. And with an inequality, you're supposed to flip this sign around. If you forget to do that on the worksheet, I'm not going to count that against you. I'll leave a little note saying, hey, just remember to flip this around, and that's going to be the end of it. It's not a big deal. So you get the answer of 26.46 newtons. So what we're saying here is if you apply 25 or 26.45 newtons of force, you're not moving that box. If I apply 26.46 newtons of force, that's the minimum amount of force I need to get the box to start moving, because the box is at rest on the floor. All right, so that's with static friction. That's just talking about static friction. Now, on the other side here, I'm going to show you the kinetic friction, and you'll see that it is actually pretty similar. So what I'm going to do then, just like I did in the previous videos, I'm going to carry this from one side of the room to the other so that you can see the chalkboard. We'll get this thing out of the way so you can actually see. There we go. All right, now we have the force of kinetic. This is kinetic friction formula. Notice the two formulas are pretty similar. All right, it's the force of kinetic friction equals the coefficient of kinetic friction times normal force. So you still have to contend with this idea of finding normal force. But this is not an inequality, it's just an equation, so you don't have to worry about flipping a sign or anything like that. Just make sure you convert the mass to newtons and then multiply by the force, by the coefficient of kinetic friction. So what I did here, you see this example, this is number one on your friction worksheet. And the reason why I put it up here is because I put an extra number in here that you don't need. So we have a 22 kilogram box, and again, it's in a complete sentence and whatnot on the paper itself, but to save time and energy and all that. 22 kilogram box moving at a constant speed of 0.84 meters per second. How much force do you exert on the box as you're moving it across the floor? So, first thing here, again, we know the mass is 22 kilograms. So we are going to take 22 times 9.8, because we want to convert that to normal force. So when we take 22 times 9.8, we get an answer of 215.16 newtons. And again, negative times negative still gives you a positive number. If you don't want to include the negatives because maybe that confuses you or whatnot, that's fine. But you got the normal force here, then you go ahead and multiply by the coefficient of kinetic friction, which is 215, or normal force is 215.6, and then the coefficient of kinetic friction is 0.20. So you multiply those two numbers together and you get 43.12 newtons. Now, notice I did not use the constant speed. All right, it's an extra number in there to basically try to throw people off. So again, you're not using the 0.84 at all in this problem. And this is number 1 on the friction worksheet, just FYI. Now, in some problems, you're asked to figure out the coefficient of friction. All right, so it's still the same idea. You're just going to manipulate this formula to where you solve for mu sub k. Or you might be also having to solve for mu sub s. I can't recall if I have you do that or not. But what you do then is just rearrange that formula, this formula here, and so you're going to end up taking the force of kinetic friction and dividing it by the normal force. Again, you still need to convert to normal force. You're going to take mass, multiply it by 9.8 to get normal force. So once you do that, plug the numbers in here, you're going to get an answer of 0 point something. If you don't, there's a 99.9% chance that you need to flip your ratio around so that you get a number that is less than 1. 0.85, whatever it is. Okay, so in talking about 2 different types of friction, right now I'm standing still. I am demonstrating to you static friction. All right, as I was moving around and kind of pointing things out over here, and if I bring the board down and whatever else, all right, as long as I am in motion, all right, as long as my feet are in motion as I'm walking on the floor, then I am demonstrating kinetic friction. When I stop moving my feet, then I'm just talking about static friction. All right. So if you have questions about this, feel free to email me. I know this can get a little bit confusing. I'm hoping this video really helps you out with how to work through the examples. You know, it was assigned today, and just know that you have till next Tuesday night, January 12th at 11:59 in the evening to complete the worksheet. So my advice to you is to start on this early. That way, if you have questions, you know, you can send them my way, or I can, you know, we can meet small group or individually, whatever. And I am more than happy to give you a hand with this so that you understand it. So take care of business and good luck.